The history of artificial intelligence, AI, is a fascinating journey that spans centuries, with its roots in ancient myths and legends, and its modern development accelerating in the mid-20th century. Early concepts and foundations, pre-20th century. Ancient myths and legends. The idea of intelligent, artificial beings dates back to ancient civilizations. In Greek mythology, Hephaestus created mechanical servants, and the myth of Pygmalion featured a statue brought to life. Similarly, the golem of Jewish folklore is a creature made of clay animated by mystical means. Philosophical foundations. In the 17th century, philosophers like René Descartes and Thomas Hobbes discussed the nature of the human mind, perception, and reasoning, which laid the groundwork for future AI research. Mechanical automata. During the 18th and 19th centuries, inventors such as Jacques de Vaucanson and Charles Babbage created mechanical devices that mimicked human actions. Babbage's analytical engine is considered a precursor to modern computers. The birth of modern AI, 20th century. Alan Turing, 1930s to 1940s. The British mathematician Alan Turing is often considered the father of AI. His concept of the Turing machine, 1936, formalized the idea of computation and problem-solving through machines. In 1950, Turing introduced the famous Turing test, a criterion for determining whether a machine could exhibit intelligent behavior indistinguishable from that of a human. John von Neumann, 1940s. Another key figure in the development of modern computing, von Neumann developed the architecture for digital computers, which became the foundation for most future computers. The Dartmouth Conference, 1956. AI as a field of study was formally established during this conference, organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. It was here that the term, artificial intelligence, was coined. The conference's optimism led to early theories that machines could easily be made to simulate human intelligence. Early AI programs and optimism, 1950s to 1970s, logic theorist, 1956, developed by Alan Newell and Herbert A. Simon. This was one of the first AI programs. It was able to prove mathematical theorems, showcasing that machines could perform tasks previously thought to require human intelligence. ELIZA, 1964 to 1966, created by Joseph Weizenbaum, ELIZA was an early natural language processing program that simulated conversation. Its doctor script mimicked a Rogerian psychotherapist and demonstrated the possibility of machines engaging in human-like dialogue. Shaky the Robot, 1966 to 1972, developed by the Stanford Research Institute, Shaky was the first mobile robot controlled by artificial intelligence. It could perceive its environment, reason about it, and take actions based on that reasoning. Expert Systems, 1970s to 1980s. AI researchers began developing expert systems, programs designed to solve complex problems by mimicking the decision-making ability of a human expert. These systems were widely used in medical diagnosis, financial services, and other fields. AI Winter, 1970s to 1990s. Despite early excitement, the progress of AI research faced several setbacks: over-optimism and disillusionment. AI researchers initially believed that solving human-level intelligence was just around the corner. However, the complexity of the task and the limitations of the technology led to disappointments. The first AI Winter, 1970s to 1980s. Due to a lack of significant progress and practical results, funding and interest in AI research decreased in the 1970s. AI research entered a period of stagnation, often referred to as the AI Winter. The second AI Winter, 1980s to 1990s, expert systems, which were initially promising, began to fail in real-world applications due to their inability to generalize beyond specific tasks. This, combined with a lack of innovation, led to another period of reduced funding and pessimism. Revival and breakthroughs, 1990s to 2000s, machine learning emerges. In the 1990s, AI research shifted focus from symbolic reasoning, traditional rule-based systems, to statistical methods, particularly machine learning. The idea was that machines could learn patterns from large amounts of data rather than relying on explicit rules. Deep Blue versus Garry Kasparov, 1997. IBM's Deep Blue, a chess-playing computer, defeated world champion Garry Kasparov in a highly publicized match, showcasing the power of computational algorithms and strategic thinking. This event symbolized a significant leap forward in AI's practical capabilities. Natural language processing advances. In the 1990s and early 2000s, Breakthroughs in natural language processing, NLP, allowed computers to better understand and generate human language. Technologies such as machine translation and speech recognition began to improve. The deep learning revolution, 2010s present, deep learning. In the 2010s, AI experienced a major resurgence due to the development of deep learning techniques, particularly neural networks. These algorithms, inspired by the human brain, are capable of learning from vast amounts of data. Advances in hardware, e.g., GPS, and large-scale datasets enabled rapid progress. ImageNet, 2012. The breakthrough came in 2012 when a deep learning model developed by a team led by Geoffrey Hinton won the ImageNet competition, drastically reducing the error rate in image classification. This demonstrated the power of deep learning for visual recognition tasks. AlphaGo, 2016. Google DeepMind's AlphaGo defeated world champion Go player Lee Sedol, a major milestone in AI, as Go was long considered too complex for computers to play at a high level. This victory demonstrated the power of reinforcement learning in tackling complex decision-making tasks. GPT and large language models. OpenAI's GPT-3, 2020, and later models have set new standards in natural language generation, enabling machines to write, summarize, and understand human language with unprecedented fluency. These models are based on large-scale training on diverse text data, and they have applications in chatbots, content creation, and code generation. AI in everyday life. AI technologies have become integral to everyday life, powering virtual assistants like Siri and Alexa, recommendation systems on Netflix and Amazon, self-driving cars, and more. AI is now a cornerstone of industries like healthcare, finance, and entertainment. Current trends and future directions. General AI, AGI. The long-term goal of AI research is to create artificial general intelligence, AGI, machines that can perform any intellectual task that a human can. While AGI remains an area of active research, many experts are divided on how soon it will be achieved. Ethics and regulation. As AI systems become more capable, issues related to AI ethics, privacy, and regulation are becoming increasingly important. The potential for job displacement, bias in AI algorithms, and the risks of AI-driven surveillance are key concerns. Autonomous systems. AI is also advancing in the development of fully autonomous systems, such as self-driving cars, drones, and robots. These systems rely on deep learning and reinforcement learning to make decisions in dynamic environments. AI and creativity. AI is beginning to demonstrate creative abilities, such as generating art, music, and even writing. This has opened up debates about the nature of creativity and the role of machines in creative processes. Conclusion. The history of AI is marked by periods of great optimism, followed by disappointments, but it is clear that AI has reached a point where its impact on society is undeniable. With continued advances in machine learning, deep learning, and other fields, AI is likely to continue transforming industries and our daily lives in the years to come. As we look ahead, the challenge will be to harness its power responsibly and ethically.